Ses geliyor mu? Sesimiz geliyor mu?
Yes.
Geliyor. Peki bunu takınca gelecek mi? Aşağı. Şimdi sesimiz geliyor mu?
Yeah.
Geliyor.
I can
Okay.
hear you. Yes. You should take.
Okay, bunu verelim.
Yeah. Okay. Evet.
What should I do?
Çok teşekkürler.
Where to press? Where to speak? Just
You can just speak here. Yeah, it is.
just.
When they speak, you hear that side. I mean, the speakers. Okay. When you are speaking, they can already hear you.
They can.
Yeah. Can somebody from the audience just say hi?
Hi.
So,
Maybe they cannot hear you.
No, I logged in from my phone. I could hear.
Hi.
Very
We can hear you.
good. They're just shy.
Yes, ma'am, we can.
okay. So, and I see. Let's start. Let's continue our session. The second part. We have 1, 2, 3, 4, 5 speakers, 5 presentations. And the first presentation is called, which the title is Challenges of Application of Invisible Artificial Intelligence Technologies in the Industrial Internet of Things. The group of authors, Gennady Dik, Alexander Bogdanov, Alexander Dik, Yasur Kiam, Igor Safkov, and Shugalov. And who will present? Okay.
Okay. Can I start?
Start. Yes.
Thank you. Dear colleagues, the title of my article is Challenges of Application of Invisible Artificial Intelligence Technologies in the Industrial Internet of Things. It will be my pleasure to introduce my ideas to you. Nowadays, due to the advanced basis of the Internet of Things, cloud technologies, as well as big data, and the intelligent industrialization, the Industrial Internet of Things is becoming an increasingly relevant issue for modern business, the public sector, or any manufacturing sector. A modern enterprise is constantly facing a multitude of external and internal challenges. External challenges are primarily related to the ever-increasing competition, rapid change in market conditions of new technologies requirements. At the same time, international problematic issues are triggered by increasingly complex production processes. As a result, any mistake in this makes will cost a lot. Thus, we have demonstrated that by using of the AI-based technologies, there is a real opportunity to obtain powerful tools for automating production processes. It will allow any enterprise ranging from commercial to government to operate much faster, more accurately, and reliably. The results process becomes more efficient. Considering the above-mentioned topics, with regard of the introduction of AI technologies for the enterprise, we focus on the use of invisible intelligence technologies in an industrial environment with a wide range of industrial application. The use of artificial intelligence allows to reduce decision-making time during production processes, reduce the occurrence of errors, ensure consistency, optimize resources, improve the security of industrial applications, and others. It's not an entire list of possibilities of using AI as part of it. We also present the results of research for this case, considering the choice of AI models for the application of visible intelligence technology in an industrial environment. To implement the above mentioned innovative features, it's necessary to include individual software components and models implemented for the corresponding functionality in the automation infrastructure. Various types of automation system should be taken into account from ERP to MES. Industrial devices for collecting, transmitting, and processing information is to be included to control loop. To ensure the continuity of operation and effective power consumption, it's possible due to one, organization of information transmission via low power wireless communication such as Bluetooth, 5G, LoRaWAN, and others. Two, energy storage through use of energy from external sources such as light, vibration of radio frequencies without charging. And three, the use of an internet element is based on advanced chips with low power consumption, low power cost-effective sensors, and energy-efficient memory. There are many examples confirming the efficient implication of 3I in the composition of industrial ed. A more detailed analysis of production processes shows that the invisible intelligence in the industrial ed plays a key role in collecting and analyzing data, which was previously quite difficult or expensive to obtain. Now it becomes possible to predict equipment breakdowns, optimize production lines, plan resource, and more. At the same time, it's obvious that these technologies are not a piece of a new innovative solution for digital production, but it makes transferring these technologies to the level of breakdown or invisible intelligence. It's an entirely new application of AI in industrial ed. As a result, the analysis of the prospects of using ambient AI in the industrial sphere makes it possible to create concept of building a software system. The systems use technology in visible industrial intelligence, SST3A, for various use cases of industrial ed. Conceptually, SST3A is a fragment of an industry framework as a set of tools and libraries for fast and efficient software configuration to determine the optional composition of the AI models used to solve a task in production. To this end, the proposed framework is decision to solve the following task. 1. Creation and editing of the enterprise digital twin. 2. Identification of typical production process patterns. 3. Identification of awkward situations, artifacts, anomalies, and deviations at various types of work in the digital enterprise. 4. Predicting based on the data collected from the industrial ed distributed environment. 5. Identification of explicit and hidden dependencies and correlations. And in the end, predicting additional factors of possible external and internal impact. According to the set of tasks to be solved as a prototype of the SST3A, we have decided on a structure with typical options consisting of the following software components. Then SC middle rail, SC creating and editing enterprise digital twin, SC identification and prevention of emergency situations, SC formation of corrective actions, SC monitoring and dispatching, SC control of reactive, preventive, and predictive maintenance, SC recommendation generation, SC ensure information and technological security of it. The use of various methods for detecting and analyzing the behavior of it industrial ed during production operation make it possible to bring both technical and information security. And in the end, the MBC storage for input data and ambient invisible models. The SST3i input receives data from various industrial sensors, digital production automation system, computerized maintenance management system, and other industrial smart system in JSON, as CSV, protobuf, XML, and other extended protocols supported by the middle layer. The input data for the industry framework is organized through the endpoints of the fast IP framework. The developed industry frameworks use the following software tools: Python, UVCon, FastP, OpenIP, PostgreSQL, and many other tools. In addition, to the above software tools, the developed industry framework uses special software tools, libraries of AI methods, which are later used in SSTV3A. And according with the capabilities of the framework, the composition of libraries of methods can be simplified and adjust depending on the purpose of and complex of tasks of the digital enterprise to be solved. This article contains a number of algorithms for the framework equation. The composition of the SSTV3A can be simplified and expanded depending on the functionality and class of tasks to be solved, both in production and in the household sphere. As a result, among the many possibilities of using artificial intelligence technology is
Please try. Maybe there are some problems in your microphone.
With my microphone.
Yes,
As
just now
result,
it's.
as a result, among the many possibilities of using artificial.
Okay, continue, please.
Artificial intelligence technologies is proposed that emphasize to prospect of its use in the industrial sphere. With the help of available libraries and tools, it's easy to set up the environment and create the most optimal solution for the enterprise. In the conclusion, we aim to show the possibility for a customer from industry or a government structure to choose and create the most suitable option for smart production while setting up the use of and based on 3A in the background. The main problematic issue of the enterprise were considered. We propose a version of the methodology for implementing an industry framework using the 3A in the industrial enterprise. First, analysis of the infrastructure on digital enterprise, identification of production processes for automation, assessment and availability and capabilities of industrial aid, as well as identification of needs for the use. Second, build up a digital twin of the enterprise, such as the creation of an existing framework as a part of the AI libraries that be connected depending on the task being solved in the enterprise. Fourth, training of the 3A modules included in the industry framework, with installation of training models into an existing infrastructure of the digital enterprise, conducting testing and determine the options for physical operation. The proposed methodology depends on the purpose, composition, complex of tasks to be solved, the degree of equipment with industrial tools, and other factors related to be plant automation in the digital enterprise under consideration. Thank you for your generous attention. It's my pleasure to answer your question.
Thank you. Thank you. I think. Okay. Questions?
Yeah,
Yes, please.
Hello. I think I have a question. You showed a diagram of the architecture. I think it was slide number 4.
Number 4.
Could you please
Number 4.
go
Okay.
back to that? Yes. So you have this kind of structure where you have MES in the middle. So can you say more about the scalability of this type of architecture? So will it work with a large amount of IoT devices, and will this MES part become a bottleneck maybe?
Let's see. I think that the scalability of the architecture in which ERP, MES, and industrial edge systems operate depends on the specifics of each system. ERP, MES, and industrial edge are different technologies, and their scalability has different limitations. Industrial edge does not provide scalability. Um, mm, A single node or server can be only handle certain numbers of devices. To achieve scalability, you need to perhaps multiply nodes or servers. Each has an instance of the software installed on it. Maybe the cost of scalability per server and node lessens for each instance of the software. IT support these elements can be significant. Thus, the scalability of the architecture in which ERP messing and operate depends on how the systems are integrated and take into account the specifics of production processes, document flow, logistics, many other communications within the company. I think so. But about bottleneck mess. I think mess now becomes a bottleneck in this situation. By the way, thank you for serious questions.
Issue with his
Thank you.
Thank you. Thank you. Maybe
I don't hear.
next steps for implementation of your architecture in practical, I think.
Uh,
Yes. For what specific, I
Interesting
think,
question.
things or
We
maybe
are currently
item.
working on this case. I hope the practical results will come up Tuesday. Maybe.
To understand how will you will implement your your architecture
Implement our
in the
architecture.
nearest future. It looks like a white paper. You describe how things should be arranged, but do you intend to implement it in practice?
Nowadays, I think nowadays we haven't any practical implemented in our maybe prototype of SST 3A as a practical.
Maybe exit from the other one.
from here. 1 second, I just.
Yeah, we seem to have some technical issues with the connection, so we will Okay, can you say something, please? Gennady?
Yeah.
Okay, we can hear you very well now.
So I think.
So did you get the answer or not? Eventually, we have some issues with connection.
I get the answer. Thank you very much. Thank you very much once more.
Okay, thank you.
Thank you.
Thank you. So the next speaker will be Nikita Gavrilov, Vladimir Korhov, Evgeny Pen, and Alexei Tokarev. Language model-based algorithm for constructing knowledge graphs from patient data. Who will deliver the report? I think Nikita. Yes? Nikita, please. The floor is yours. Nikita.
Nikita, we cannot hear you.
Can you hear me now?
Yes, please.
And can you let me share my screen? So
Yes, please share.
yeah, can you see my screen now?
Yes, very good.
Okay. My name is Nikita Gavrilov, and today I'll present our research on constructing a knowledge graph from patent text using language models. So patents are key source of information about technological innovation. They describe new inventions and implementation details. Because of this, patents are widely used for analyzing scientific and technical progress. However, due to the large volume and complexity of patent text, manual analysis becomes inefficient. This creates a strong need to automated methods that can create knowledge from patent documents. This work presents a method for discovering relationships between patents text. The goal was to develop a technique that considers both the structure of patent data and the practical limitations of working with it. Several challenges were addressed: structural heterogeneity, high variation in terminology, large volume of data, and no label corpus for supervised learning. Because of these issues, manual annotation is expensive and impractical, especially for large datasets. As a result, the proposed method should work without manual data labeling, scale to large collections of documents, and extract useful knowledge without extracting specific entities or relations. To achieve the stated goal, the following tasks were addressed. First is development of an algorithm for constructing a graph. Second is application of a clustering algorithm and interpretation of the results. The study used a large dataset of Russian patents from the RUPAT database provided by the Federal Institute of Industrial Property. During preparation, only patents with up to 5,027 tokens were selected. This threshold corresponds to the 99th percentile in the token count distribution. Graphs are a convenient way to represent, store, and analyze knowledge. The main advantage is scalability. It means that new nodes and edges can be added without changing the structure of full graph. Also, standard graph algorithms can be applied for further analysis. This work proposes an alternative to the traditional knowledge graph, which represents knowledge as a triplet in form entity, relation, entity. In the proposed approach, entire document are used as a nodes. This removes the requirement for named entity recognition and relation extraction. This slide shows the overall data processing pipeline. It includes 4 main steps. First one is extract text fields, and then vectorize these texts, store embeddings in a vector database, and build the graph based on the vector similarity. the claim section of each patent was selected for embedding. The section contains the most formal and important technical content. Text factorization was performed using the Roberta large model, a transformer-based language model trained on a Russian language corpus. This model was selected because it performs well in Russian superglue tasks, especially in paraphrase detection and semantic similarity evaluation. The face library was used for storing and searching embeddings. The index FlatIP index was applied, which provides high performance without accuracy loss. Then GPU is available. To determine the optimal number of neighbors, an experiment was conducted to analyze the impact of the key parameter on graph structure. The optimal value was found to be key equal to 10, ensuring that each node remains sufficiently connected to other nodes. The Leiden algorithm was used for clustering. It works in several steps: local movements of nodes, refinement of communities, and aggregation into supernodes. The resolution parameter controls how many clusters are produced. Shannon entropy was used to measure how evenly documents are distributed across clusters. This helps avoid forming a few large clusters. On this slide, the plot shows the changes in modularity, normalized Shannon entropy, and the number of clusters depending on the resolution parameter, which controls the granularity of the clustering. This resolution parameter was determined using normalized Shannon entropy, which evaluates how uniformly nodes are distributed among clusters. This metric helps prevent the creation of overly large clusters and promotes a more balanced partitioning. As the result increases, the number of clusters grows. Clusters become more balanced, and modularity decreases. The decrease in modularity is not critical if it leads to the better cluster uniformity. After clustering, a new graph was created, and in this graph, first, each node is a cluster, and the second is two clusters are connected if there's at least one edge between their nodes in the original graph. This produces a smaller and cleaner representation of the pattern space. A subgraph is shown in the figure. Cluster descriptions were generated using the Mistral language model with 7 billion parameters fine-tuned on Russian text. Due to memory limitations, only 5 documents per cluster were randomly sampled for summarization. This reduces computational cost and also checks the consistency of the cluster. It works like if documents in the sample differ too much in content, the generated description may be inaccurate. The slide shows an example JSON file that stores keywords and pattern ID used for cluster summarization. That's an example of JSON. As a result, a compact and clear representation of pattern data has been created. This structure allows for better understanding of the relationships between inventions and supports applications in intellectual property management, scientific research, and technology trend analysis. Further improvements can be made by using full text data in the summarization stage or by enriching the graph with metadata like authors or filling days. And I think that's all. Thank you for your attention.
Thank you. Your questions, please. Okay. Nikita, I have one small question.
Yeah.
And what is the attitude of the physicians for your work? Are you working with the real physicians, with the real patients?
Let me...
I see.
Can you please repeat the question?
I think I am working with the real data.
Yeah.
Yeah, and what is the attitude of those who are involved with this activity to your work?
You answer about my co-workers or about authors of these patents?
Your co-workers.
My co-workers, yeah. This work was made this BioGeoHub and EADREAD collaboration, and these organizations give me data, give me Russian patent text in XML format, and this was the impact on this work. Also, they helped me with information. They answer my questions while we worked on this project, on this work.
Do you work with the real customers? Maybe people who want to find something, some patents?
Not now, but now we are in the process. We're working with real customers.
I see. Thank you. Any other questions? No? Okay. Thank you once more. I think the next presentation, the group is of the authors headed by Nadezhda Щеголева, the co-author Evgeny Batulin, Valery Khladkov, and Alexander Bogdanov. Hierarchy of vertical storage. Please, who will present?
Can you hear me and see the presentation?
Yes, yes, please. Everything is wonderful.
Okay, thank you. So, good afternoon, everyone. And today I want to present a hierarchical virtual storage, an approach to integrate and manage large-scale distributed data sources. And let's begin. First of all, as we move forward in a data-driven world, data consumption is growing at an unexpected pace. And to keep up with evolving business requirements, data storage systems are under continuous development. Today's systems offer powerful distribution computing capabilities, support both structured and unstructured data, and provide reliable storage. However, they often fall short when it comes to integrating widely distributed data sources across organization boundaries. This integration challenge motivates our work. So, what are the data providers and data consumers today? Data consumers and data providers are large language models and IoT devices. But the issue here is that both of them remain distributed. There is no middleman. Therefore, a more flexible, virtualized, and hierarchical approach is needed to bridge this and support the next generation on analytical workloads. And to address this, have a look at technologies we are using today. So we can see that data storage has evolved through several key paradigms. First, there was a data warehouse for processing structured data. Then came data lakes for raw unstructured information, enabling to skip upfront processing. Each step has aimed to improve scalability, flexibility, and time to insight. Yet, the full integration of disparate data domains remains undone. So the solution, which we call data mesh, which provides single-point access to multiple data stores through logical virtualization, tries to solve that. So we want to know what is data mesh. A data mesh is a design pattern that introduces an intermediate virtualization layer to unite separate data domains. It builds on a classical storage systems like data lakes, data warehouses, and sometimes even they hybrids by adding a federated metadata and access layer. This layer abstracts the underlying storage details, enabling consumers to query and combine data without needing to understand the physical location or architecture of each domain. It creates a united logical data fabric over multiple autonomous storage nodes. This is the example of such system, and more should I say, this is a pattern to build it, not a realization. And this diagram illustrates a basic data mesh architecture. Each organization or business unit maintains its own node, which is something we want to combine in a single system. Consumers then submit their queries to the mesh, if we can see on the left, which routes and aggregates results from the individual nodes. So to implement this system, we need some modern technologies. Let's have a look at them. First, we are talking about container clusters, which replace virtual machines, offering agility and scalability. Cluster managers automate deployment, scaling, and provide us high availability. Microservice architectures allows modular services such as metadata, query brokers, and adapters to be deployed independently, so we can build our system to fit our needs. Grid systems demonstrate high cross-organization process integration, which was an inspiration for that system. Hierarchical storage systems provide scalable tiering from fast layer to slow stores. And the last one is logical virtualization, which hides complexity from consumers, presenting a full united interface. So to validate our approach, we built a prototype organization node. We are talking here about single node, equipped with 2 data lake storages. A data lake migration service for moving data across layers, and a metadata storage to manage seamless future integration into larger mesh. And here's the illustration which shows this implementation. The data lake store raw and process data. The data migration service orchestrates transfers between layers, and the metadata storage inside the migration service works storing our metadata. These components run as a containerized microservices in our cluster, ensuring modularity and resilience. And how we can integrate those nodes into the data mesh architecture. To assemble a full data mesh, we introduce a higher level of logical virtualization atop individual nodes, which were explained earlier. This global mesh layer provides a united metadata catalog for aggregating entries from all nodes, extract pipelines from each node. Through this architecture, we achieve a single large storage fabric that spans multiple autonomous systems while presenting local control and governance. And these are the benefits we see of our system. We see that system will be agile and have high availability because we are leveraging proven cloud technologies, ensures rapid reconstructing and high uptime. Other thing is flexibility. Each node or each layer can use the best fit technology for its domain. We have high reconfigurability, which organizations can use to adapt the system for them. And high scalability is a crucial one because the system handles massive data volumes and diverse formats without looking in a single representation. Why this system is very important for us? We can see that emerging demands such as large-scale scientific experiments and advanced AI workloads require seamless access to data at new scales. To meet these challenges, we propose organizing existing technologies into a data mesh architecture. By combining virtualization, distributed computing, and modern storage techniques, we can integrate diverse data domains into a connected, scalable system, which is the evolution of big data infrastructure. And to conclude this work, I would like to say that our hierarchical virtual storage model, which called the data mesh, represents a significant step forward in big data system design, especially for organizations managing distributed sources and using complex analysis. By building on established components and introducing novel federation layers, we enable more comprehensive, efficient, and adaptable data ecosystems. Future work will focus on optimizing query federation, performance, and working on more high scalable systems. Thank you for your attention.
Thank you. Please, questions. Okay.
Hello, Evgeny. So my question is, so now it's mostly analytical research, right? Like you build the model of the system and you try to analyze it now. But yet you do not have any practical evaluation. Is it correct?
Only part of it. So we already made some step in this research, which I called a node. Here's the representation of it, which is we construct and already working in organization called Joint Institute of Nuclear Research, but we won't have time to build a full distributed data mesh because there are need for several organizations to integrate to build it.
So you built one of the core components, but you still need time to build the full system, and you still need probably time to evaluate even the single component. Or you cannot evaluate a single component until the full system is built. What is your opinion? Because I wonder how it will behave in practice later on. And what do you plan to do with this in practice? How do you plan to evaluate that it is good? So it is scalable, it has high performance, etc. So all the qualities that you mentioned. What is your plan for proving that your solution is really good?
So if we look at already created implementation, which is single node for organization, we can replace our data storages with our implementation, which is in the future allows organization to connect into global data mesh. So right now we can test the system, store data in it, and then other organizations start to using this system too, then they can integrate into a single layer. So right now, each organization which is implemented this solution can use it as they like, I should say.
Yeah, well, my point is that I think you should plan this kind of investigation of how the system behaves, so some kind of tests. So you put different amounts of data, you put different amount of components, and you should have some plan of this testing, of this practical evaluation. Just think about this, and maybe next step will be very interesting from practical point of view. Thank you.
Yeah, thank you.
Other questions? And my question is in continuation of Vladimir's questions. Maybe you will be able to make some preliminary evaluation of metrics. Why the previous constructions, the previous architecture is not so good, and you will be better. Maybe you will theoretically estimate some metrics and show that your architecture is better. Is it possible to do this? Why the previous is not so
we want
efficient?
to compare those systems, right?
Yes.
Is it of course possible, but right now we are working more on architecture, how to connect those things. And when it created, when at that moment we can talk about comparing them.
Okay, thank you. Thank you very much. So the next, I think also the group of 4 authors headed by Nadezhda Щеколева, then Nadezhda Pronina, Natalia Zalutskaya, and Jasur Kiyamov. Automated classification and segmentation of brain tumor of MRI images using voice-based machine learning.
Hello, everybody. Can you hear me?
Yes, we hear you, but don't see the presentation.
1 second. Can you see it now?
Yes.
Thank you. So, good afternoon, everyone. My name is Nadezhda Plonina, and I represent St. Petersburg State University. Today, I would like to present the results of our research titled Automated Classification and Segmentation of Brain Tumors on MRI Images using Superpixel-based machine learning. So, brain tumors are among the most dangerous and diagnostically complex diseases of the central nervous system. According to the World Health Organization, over 20 million new cancer cases were recorded in 2022. Although brain tumors account for only about 1.4% of male and 1.2% of female oncological diagnoses in Russia, and their complexity and mortality rates remain exceptionally high. MRI is the gold standard for brain imaging, but manual interpretation is labor intensive and error prone, especially under the time pressure or in low resource environments. So, this is why we focused on developing an automated pipeline that could support doctors in the early detection and localization of brain tumors. Our approach is two-stage. First, we use a classifier to determine whether their MRI shows pathological changes. If the image is marked as suspicious, we proceed to segment the abnormal region. The strategy improves efficiency by avoiding unnecessary segmentation on healthy images, thus saving computational resources and reducing diagnostic time. We based our experiments on the LGG MRI segmentation dataset, published on Kaggle and sourced from the TCGA LGG collection. It includes MRI scans from 110 patients, each with manually labeled tumor masks. All images are stored in TIFF format and cover multiple axial brain slices. On this slide, you can see 3 examples of original MRI scans on the top row. The third one clearly shows a tumor region in the right hemisphere. In the bottom row, we show the corresponding ground truth masks, where white areas mark the annotation tumor zones. And these binary masks were created manually by medical experts. To enhance image quality before analysis, we applied median filtering, gamma correction, and morphological operations. And these preprocessing steps improved contrast, reduced noises, and eliminate small defects. Also, from each image, we extracted a rich set of statistical and textural features, including mean, intensity, entropy, and etc. Technologies that we used is Python, Streamlit, scikit-learn, and another libraries. So, we evaluated several classification models, including SVM, KNN, and random forest. However, the best performance came from a hybrid SVM-KNN classifier. The hybrid approach was inspired by the paper MRI brain cancer classification using hybrid classifier SVM-KNN by Mitchell, published in 2015. In their study, this combination achieved higher accuracy than the either algorithms alone, especially on small and noisy datasets, which is typical in medical images. Our results confirmed its strength. The hybrid classifier achieved near perfect accuracy and recall, as for random forest as well. It successfully identified almost all pathological cases and made no false prediction on healthy one. So it makes it a reliable tool for filtering. As for segmentation, we tested several algorithms, including OTSO, thresholding, and Slick Superpixel. While OTSO was too sensitive to noise, and contrast variations, Slick. On this slide, you can see the results of OTSO experiments. So this slide shows the Slick results, and we can see that the Slick provides better visual consistency by grouping similar pixels into compact region. And in particular, you can see we compared how the superpixel segmentation behave when we use 2, 3, and 4 clusters. And this visualization clearly show the strengths and limitations of the method. especially in distinguished brain structure from background region. So the conclusion, our two-stage system combined high accuracy classification with superpixel-based segmentation, reducing diagnostic time and increasing reliability. It's particularly useful in clinical environments where time, data, or expert resources are limited. In the future, we plan to enhance segmentation by including school structures, and we would like to use deep learning methods like UNet. Thank you very much for your attention.
Thank you. Any questions? Nadezhda, sorry, I don't understand maybe. Are you working with the real patients, with the real physicians? Are you in close connections with the people who treat the patients?
No, the dataset is open and it's published on Kaggle. But the images which I showed you on this slide is the real one. So it's real patients' pictures, and experts, doctors, they manually divide this picture, and they show, they create these masks which show the tumor.
I see. I want to know the attitude of the real doctors for your work. Are they accept your results or not?
Natalia Zlutskaya is one of the authors, and we work with her, and also we in contact with the institution named Bechtereva in St. Petersburg, and we are in future. I'm going to go to the high level of education in my university, and we are going to contact with them, and they will provide us new and real examples.
Thank you. Good luck with the activity. Thank you. Any other questions? No? Then, okay. Thank you. Thank you. I think the last presentation, also by the group headed by Nadezhda Щеголева and Maria Gladkaya and Gennady Dik. Optimization of Fresco assembly for accuracy.
Can you see my screen?
Yes, now yes.
Hello everyone. The title of my article is Optimization of the Automated Fresco Assembly for Accuracy. It would be a pleasure to introduce it to you. Archaeology is a field where the restoration of an artifact from its fragments is of great importance. The relevance is determined by the following: protection and preservation of cultural heritage, evaluation, educational value, increasing the efficiency of archaeological research. The algorithm proposed for solving the problem of assembling frescoes consists of the following steps: preparing input data, extrapolation of graphic information for fragments, assembling a fresco using fast Fourier transform operations, and assessing the quality of assembly to select a solution from the solutions proposed by the algorithm. Let's look at each step in more detail below. The first step is to prepare the input data. For the convenience of preparing the input data, an algorithm was developed that automatically splits the image into fragments using a given mask. The input is the original fresco image, and the mask simulating splits. The output is several images corresponding to each individual fragment after splitting. The areas outside the fragments are painted black. The second step is to extrapolate the boundaries of each fragment and restore the image on the extrapolated areas using texture drawing and synthesis. This is done to restore the lost edges of fragments. An algorithm for extrapolating graphic information is proposed. Briefly, the essence of the algorithm is that the target area is selected and priorities and Etherford strength functions are calculated for patches lying on its border. This term means increasing the priority of a patch if the Etherford falls in the area of a patch. Next, the patch with the highest priority is found and the image from it is copied to the target area in the direction of the Etherford. Then the priorities of the patches are updated and the algorithm works until the entire target area is filled. An example of the result of the algorithm described above is presented on the slide. Next, when all fragments are extrapolated, it's necessary to find a transformation that gives the maximum correlation between fragments. Such transformation can be expressed through fast Fourier transform operations. The first part of the formula reflects the value of the correlation between fragments, and the second takes into account that the fact that the fragments should not intersect. After all the fragments are placed, the cost function is calculated to evaluate the quality of the assembly. It consists of two parts: the sum of the similarity conditions of the graphic information on the fragments and the geometric constraints for all points on a predetermined board or space. The formulas for both parts are presented on the slide. Thus, the complete algorithm of automatic restoration of frescoes looks like this. You can see it on the slide. Here you can pay attention on the fact that the algorithm can find several solutions, and to find the best one, it suggests to restart the algorithm if the current solution has reduced the cost function compared to the previous solution. Experiments were conducted to select image features that will be used in further assembly. For this experiment, structural and textural features were selected. Uh, Structural features such as histogram of oriented gradients and textural features such as gray level co-occurrence matrix, Gabor filter, and local binary patterns. Let's move on to the practical part. Uh, the first step was to select image features from those described above. For this purpose, an assembly experiment was conducted on two fragments. The slide shows the initial arrangement of the fragments and the examples of the extracted features. Based on the result of experiments, the histogram of oriented gradients, local binary patterns, and Gabor filter where features were selected as image descriptors used to restore the frescoes. The gray level co-occurrence matrix method was excluded from further consideration due to the demonstrated low accuracy. The following metrics were selected to evaluate assembly accuracy. Texture affinity index is a metric used to quantify the degree of similarity between the textures of fragments. It measures the difference between the textures of two images using texture descriptors. We've chosen the local binary pattern as a descriptor. The LPP-based method uses the Hellinger distance between the histograms of the reference image and the test image. And the second metric is Euclidean match accuracy, and it's a metric used to measure the accuracy of the predicted coordinates relative to their two values. For a coordinate prediction task, the matching accuracy is usually defined as the average Euclidean distance between the predicted and true coordinates. Let's move on to examining the results of the algorithm operation. An experiment was conducted with an input data set consisting of 6 fragments. The results are presented on the slide. And also an experiment with an input data set with missing fragments was conducted. The results are presented on the slide. The proposed approach allows finding the best placement of fragments that ensures maximum correlation and continuity of fragment textures while respecting geometric constraints, which consist in ensuring that the fragments do not intersect each other. The presented algorithm has high accuracy of 97.8%. Unlike existing algorithms, the algorithm presented is in this paper capable of working with fragments of arbitrary shape. This gives a great advantage over main algorithms that works only with square or rectangular fragments. For the archaeological field of research, this is a very important point, since artifacts found during excavations never split into rectangular fragments. In addition, the advantages of an algorithm include the fact that the result remains stable when fragments or their edges are lost under the influence of various factors. This is an important advantage because the loss of fragments, edges, or fragments themselves is not uncommon for archaeological artifacts found during excavation. It's possible not to know the speed of work. Optimization is achieved by using fast Fourier transform to find the best placement of one fragment relative to another. It contrasts to the fact that there were solutions in other papers where complete enumeration of all possible placements was proposed, which would require huge computational cost and resources. One of the important advantages of the presented algorithm is that any image feature can be taken into account during assembly, which allows to take into account any textural features of the image that can improve accuracy of assembly. Thank you for attention. It's my pleasure to answer your questions.
Thank you. Any questions? Yes, please, Vladimir.
Maria, you showed us 3 algorithms that you compared, and you showed us some metrics. Maybe you could go to that slide. I think it was like 3 or 4 slides back. The table with numbers.
This?
Yeah, maybe this one. Yeah, and you have this plates down there. If you can. You have access to the screen, so if you can just hide it. If you do the low.
Can you repeat the question? I didn't.
Ну смотри, у тебя снизу плашка, которая закрывает нижнюю строчку. Можно ее убрать?
Sorry.
Вот на скрыть. Okay. So in fact, my question just in general relates to this table. So the question is that first you got these numbers based on the data set. What was the set of the data set? Was it just this single image of Madonna, or was there something else?
I've generated this data set by myself. So there is only one.
Only one image.
Yeah.
So you got one image, and you only on one image you made your experiments.
On 2 images.
2 images.
What? And this.
And this one.
With missing fragment. This experiment. And previous experiment, just to check if algorithm is okay.
Okay, yeah, that's very good. But my question is like on the generalizability, or how general your result is. So if you take some other images, would it also behave well? If you only took 2, then that's okay, but maybe that's the future work. So to evaluate the algorithm on much more data and see how it works.
Yeah, our
And then
plans for future work is to check algorithm on data sets with more pieces and more different cases with missing pieces or
yeah, exactly.
mixed
And
fragments from
Mhm.
different frescoes.
Yeah, that's a very good plan indeed, because the second question is also related. So these algorithms, can you distinguish, so which one is the best one or which one is the worst one? For me, it seemed that are pretty similar, at least the images that you show, how it composes the general image, the total image, it looks more or less the same. So sometimes you have this big gap, sometimes not, but it's not that big. So can you say something now in general, your current opinion? Can you distinguish some of these algorithms and say this is the best one or not yet? So can you compare and give the evaluation?
I think you didn't get a little bit my job because the algorithm is one, but I checked its work on different features of images.
Okay, different metrics, yes, different metrics.
Different features like histogram of oriented gradients, local binding patterns, and Gabor filter.
But you got these different images. So you got different results as we see for Hawk, for LBP, for Gabor filter. So you got this differently. How, if you have only a single algorithm, as you say now?
Because they describe different nuances of textures. So
you used your algorithm and you try to optimize these different metrics. So for each image,
yeah, I've
use the
researched
algorithm.
how this metrics how my algorithm works on these metrics.
Yeah, exactly. So again, the question is, you can say if your algorithm works with specific metric, you can somehow call it like specific algorithm. So can you say that any of these metrics is the most relevant and better than the other one? So which one shall we use now? So you made your research. What is the conclusion then? Which one of these metrics we should take?
We should take histogram of oriented gradients because the Euclidean precision is the lowest. It means that coordinates of fragments placement is most the same with original placement. So that is.
Okay, thank you very much. Yes, that's clear. Thank you.
Thank you. So our session is over. Thank you, all participants. See you in the next session at 4 p.m.
Thank you.
Thank you.
You wish to keep your system connected? I think you're the chair in the next.
Yeah, probably we should use my laptop today, the whole day, but tomorrow.
Tomorrow I bring mine. I can't rely on
Because it's so either it has weak connection module because we connect to the same network now, also network.
Okay, okay.
Same, then just enough to capture the network.
Yes. I think the Wi-Fi driver is not good because the connection is too weak.
Yeah.
So tomorrow I will bring mine. It gave me too much stress today.
Yeah.
If you allow me, I will just put the break screen on.
Yeah,
Okay. Okay, everything is in Russian, I think. I can't.
What shall I do? Do you have the screen or?
I have a link, and that link takes you to this.
All right, welcome back, everyone. So we are about to continue our session on the Scientific Computing Infrastructure Workshop. And I would like to invite Alexey Subotin, Natalia Zhukova, and Helena Stankova. And I believe Alexey will be doing the presentation.
Yes, of course.
Alexey, welcome. So we can hear you very well. Could you please share your screen?
Can you see?
Yes, we can see your slides. Yes, and we can hear you very well. So,
Good
please.
afternoon, ladies and gentlemen. I present to your attention a report on the topic Intelligent Browser Window System for Visualizing Events Detected from Video in Distributed for Computer Environment. My name is Alexey Subotin. I am a postgraduate student of St. Petersburg State Electrotechnical University. My presentation is funded by a grant from the Russian Academy of Science. I work in the subway and teach students. Next slide. The main directions of this research for computing, distributed computing, Windows system creation, event visualization, intelligent subway video surveillance system, intelligent assistant, event and pattern recognition. Relevance. Today it's important to create a Windows system in the browser, as the standard Windows systems have a long history and are overloaded with a huge number of service functions. Popular Windows systems are not modern and do not support the intelligent video surveillance system at the core in particular. Event visualization and neural networks. Support for video server in a for computing environment should be a priority in the core of the Windows system in the browser. Restrictions. Existing systems have a number of limitations that appear when they are used for visualization of events that are the low speed of the application, lack of mobility, configurability, and lack of universality. Work under only Windows 7. The problem is proposed to be solved by creating an intelligent video system in the browser for visualization of events and video server settings in a for computing environment. Next slide. Comparison. We consider systems have different capabilities. X project provide basic features in the Go version, but the features become much more with the accession of advanced versions of X-Protect. X-Protect is slow and requires installation, while Axioma works without installation and runs very fast on big computers. Without the program, we only work under Windows, but ZoneMining can also work under Linux. iSpy can work with mobility devices. SunHound Video runs on Linux and macOS. At-home video streamer can work with devices. iLine runs on older versions of Windows. Netcom Studio works through a browser. Comparison of the features of the considered systems is presented in next table on next slide. The systems are compiled using the following parameters. First is operation of the system without installation. Second point is work on Linux. Next point is work with mobile devices. Next point, work on macOS, work with smart home devices, work with older versions of Windows, work in browser, high speed of visualization, mobility, configurability, and universality. We can see on this slide different systems of window visualization events. Comparison of the considered features and limitations of the considered systems. What's the problem? Reason why Windows systems are created in the browser to visualize events and video service settings. First point, faster loading and operating of a window with a website on slow and technical computers, embedded systems, where the standard Explore task from Microsoft works slow. Second point, support for devices of complex technological devices and monitors. And last point, custom applications based on widgets, function graphs, complex tables, tooltips, running lines, and mini applications. Result of analysis of energies showed that they lack mobility, speed, versatility, and configurability. This can be achieved only if the Windows system is used instead of the standard Explorer task. It will allow to ensure high speed and also mobility and versatility. Science web browser can be used on all devices and operating systems. All three criteria directly after the speed of personal interaction when solving applied tasks. Solution method we can see on this slide. Browse the Windows system for settings and visualization of events in the intelligent video surveillance system on the subway. Binary incapability can be solved to creating a Windows system in the browser. First, the kernel functions are loaded when the drivers and graphical environment functions, and when not, the application is launched, but the browser, which corrects instead of the application to the video server in the fog and visualizes the events and settings in the Windows system. Windows system prototype we can see on this slide on the center. Dynamic loading. Processing of dynamic requests working with DBMC, uploading and processing files on the video server in fog is done through the PHP language science in the very fast in execution and easy to understand with good and reliable documentation. In the child frame, in one frame type, the dynamic.php page opens with is a PHP script with parameters. Case study. We authors of a study develop a website that runs entirely on JavaScript, implementing a Windows system in the browser. In the center on a next figure of the website were two windows. The window at the top shows the version of the website, and the second window at the bottom of the screen visualizes events. At the top of the screen were a status bar reminiscent of macOS or the main menu of the application, a form element in the Windows application designer. In the upper left corner additional information about the detected event is shown in the small sub-windows. Sub-windows are created according to the fast principle very quickly, almost instantly. Visualization of events is based on using for distributed computer and container or virtual machines. In example, the parallels desktop of for Mac Visual Machine based on Qt Creator. An important element of the proposed solution is the possibility to take into account the user's preference, which are configured in additional windows that can be opened through the main menu of the application in the browser. It allows to set the color, size, position of windows, and much more using a neural network, or all those settings can be changed manually using buttons, checkboxes, drop down list, and other. We can see on this slide on the center Windows system in browser for settings and visualization of events. Next slide. The developed Windows system was tested in St. Petersburg subway. I work in the subway and teach students. In the subway, such as broken escalator steps was trained using datasets, images, and a control dataset images. The dataset contains the images of the following classes: broken steps, fire, flooding. The architecture of a neural network based on NumPy with 14 layers, sampling and convolution was used. The features of a NumPy algorithm are homogeneity and other uh, NumPy tools work very quickly and have a higher data processing speed in C and C++ when in Python. There are no problem with training using the NumPy algorithm in the process of machine learning. Science NumPy is implemented very well. A dataset with images that were used to train the model can serve as a virtual graphical material. To examine the images carefully, just download the project, run the application, build and datasets will be loaded into the project on NumPy in the directly with the sources codes. The neural network models was trained to identify patterns during 12 hours on NVIDIA GeForce RTX. Subs Windows system classified correctly more than 92% of images and showed a high efficiently with has estimate based on 5 parameters we can see on under this slide. 5 service, ambulance, and other. Next slide. Comparison of the systems by response time of various services. In the subway, we can see on this slide in the table. With the system, Explorer, Xprotect, Xioma, ZoneMinder, ASPI, Surround Video, and other. More about Windows systems. The bar charts created based on the experimental data visual illustrated on the figure shown on the last slide, how faster win subs in person compared to other visualization and events monitoring systems. The slowest compared to win subs was online video surveillance systems, and real competition is X products. Netcom Studio and iSpy programs are at approximately the same level. Xioma and Explorer program are also at approximately the same level. After the VI-Line video surveillance program, the second place on the slowest operation in the take by at-home video streamer, perhaps due to the adaptation of the program to home use. WinSubs is faster with its analogies. We can see on this slide first position on this graph. Consumption. The authors of the presentation consider creating a Windows system in a browser instead of a standard Windows desktop. The key advantage of the proposed system is the high speed of rendering the Windows system. Another distinct feature of the new Windows apps by my work Windows system is variable as it can work on all devices and operating system. In addition, the system is mobility and easily portable, so it can be launched by a video service operator on the table, and program is easy to configure. Visualization of events based on distributed fog computing has significantly increased the speed of the Windows system in the browser and instead service performance. Using the development system in the subway showed an increase in the efficiency speed of work of personnel by 20.3%. The science component of the study is a methodology for solving a wide range of problems where it is necessary to determine events in the system with limited resources on non-standard hardware. For example, embedded computers, Raspberry Pi, Melander, and other. The system was slowly tested on the control dataset for 2 weeks with 47 access IP cameras. In the future, it's planned to use a neural network with controlled elements which will take into account an expected list of parameters such as a color, localization of the screen, window size, frame events, and personal entered the door, and many other for adaptive dynamic adjust of the Windows system in accordance with use preference. The choice fell on this neural network since it supports additional training in dynamics, and the neural network algorithm works well when recognizes images in motion. Such a neural network will be deployed on video server in the next version of the program. The proposed approach can be applied not only in the subway when I worked, but also in other premises with limited spaces, a cruise liner, submarine, school, kindergarten, shopping center, where it is necessary to conduct investigations and monitoring. Thank you for your attention.
Thank you, Alexei. Please, questions from the audience? No questions yet. I have a question. So, Alexei, could you please clarify? So, you use your system to collect video data from cameras in fog computing, and you show the results in this browser Windows system, and you told about the scenario with neural networks. So do you also have separate server that performs this neural network processing and then feeds the results to the browser windows? So what is the whole setup?
We prepare neural network in fog computing environments and visualizing events from the browser, because browser very fast and through connection on other service for TCP/IP protocols.
But where do you run neural networks? On what kind of devices then?
Devices, ПК and planchette and smartphone.
So you run a neural network right on those devices?
Yes, this
So
Windows system can be running other devices.
okay, thank you. Do we have more questions? No questions. Thank you again, Alexei. Thank you. And we continue to the next talk by Nadezhda Shogoleva, Piotr Tomka, and Natalia Zaludzkaya, who is going to present. Nadezhda or Piotr? I think Nadezhda is online. Nadezhda, are you a presenter? Okay, let me clarify. Nadezhda, can you hear us? Okay, let's try to fix this technical delay. I'm in contact with Nadezhda.
Dear colleague, do you hear me?
No, we cannot hear you, but we see that you
Okay,
try to say something.
I'm hear you in this browser, but I don't understand why you don't hear me.
Huh? What?
It's HDMI.
Ah, okay. Let me. Can you say something again, please?
Do you hear me?
We have some. Let
Nothing.
me check. Can you say something again?
Hello, dear colleagues.
Okay, something is. Maybe it's on our side. Now we can hear you. One moment.
Okay.
With the projector, so now the problem is on our side. Please wait a moment. Okay, something. Okay. All right, I think now is good.
Hello,
So
dear
could you
colleagues.
please share your screen?
Just a moment.
We can hear you, but we cannot see your slides yet.
Okay. And now?
Yes, very good.
Can I start?
Yes, please. We see the last slide now, but I think that's...
Just a moment.
Yeah.
Okay, I think it's the first slide. And you...
Yes.
Okay, thank you very much for waiting for my report. Dear colleagues, today I'm presenting an investigation of Alzheimer's disease using a sequential analytical pipeline for higher dimensional and lower sample biomedical data. And in this work, a comprehensive approach was developed for the processing high-dimensional medical data with special attention given to addressing the issues of imbalance observation to feature ratios. The key goal of our study is to construct a universal pipeline designed to extract stable patterns and potential biomarkers under condition of limited observation and high data dimensionality. And against the backdrop of global population aging, the issues of dementia is becoming increasingly relevant. Alzheimer's disease accounts for up to 20% of all dementia cases. Yet there is still no effective treatments, and the disease is difficult to diagnose early, which increases the burden of patients, their families, and the healthcare system. Diagnosis challenges are partly due to the fact that classical biomarkers such as positron emission tomography, PET, or cerebral spinal fluid analysis are invasive and very expensive. Therefore, less invasive examination methods such as MRI, EEG, or blood test are increasingly used. There is allowed to collection of large volumes of information. However, this gives rise to another problem. The generation of large amounts of heterogeneous and high-dimensional data requiring special processing. The aim of our work is to create a universal pipeline for processing and analyzing medical data with an emphasis on structural validation of the obtained results. The task set to achieve this goal, and we will present it on the slide. The initial data set, as you can see, consists of 54 patients divided into 6 diagnosis groups. Various clinical indicators were collected for each patient. However, only EEG and MRI data were considered in this study. Each modality was pre-processed separately, including the removal of patients with missing records, checking the duplicate entries, and handling missing values. As a result, 5 subsets were formed, 3 homogeneous by data type and 2 combined. As shown in the table on the slide, the ratio of observation to features in each subset demonstrates a strong imbalance. And after forming the subsets, the data was normalized for further methods to work correctly. Then principal component analysis, PCA, was applied to reduce noise and feature correlation. PCA also simplifies the data structure and prepares it for nonlinear dimensionality reduction. Using PCA, dimensionality was reduced to 50 components, allowing for maximum information retention while significantly reducing the number of features. And next step was to determine the intrinsic dimensionality of data, the minimum number of parameters sufficient to describe the structure without significant loss of information. This was calculated using a maximum likelihood estimation method. The result showed that the intrinsic dimensionality of data in different subsets range from 5 to 10 dimensions. This estimate was used as a touch dimensionality for further data projection. Next, we applied UMAP method. UMAP is a nonlinear dimensionality reduction technique that aims to preserve both of the global and local data structure. Data from the 50-dimensional PCA space was projected into a space whose dimensionality corresponded to the previously determined intrinsic dimensionality. UMAP hyperparameter were turned to form more compact projection without overemphasizing local structure. After dimensionality reduction, clustering was performed using 3 algorithms representing different approach: hierarchical, density-based, and graph-based. These were agglomerative clustering. It was 3-method agglomerative clustering, HDB scan, and spectral clustering. And this choice of algorithm allowed for the exploration of both compact and sparse structures in the data. The quality of clustering was evaluated using internal metrics. The main metrics were the silhouette score and the density-based clustering validation method. The silhouette score assesses the separability of clusters by comparing distance within and between groups. And density-based clustering validation, in turn, is based on density structure and additionally accounts for the presence of noise objects. This combination method metrics covered both geometric and density characteristics of clusters, which is especially important when using different clustering algorithms. And after obtaining low-dimensional data representation, the next step was to turn the clustering algorithm. For each method, hyperparameters was selected using Bayesian optimization. The target metrics for optimization was chosen to best match the algorithm specific. In addition to internal metrics, statistical text were used to assess cluster significance. Several constraints were considered when selecting optimal hyperparameters. These include the requirement for statistical significance of the resulting partitions and for RGB scan, constraint on the proportion of the noise points, no more 35% of the sample. Cluster stability testing is necessary to ensure that the identified partitions and reproducible with minor changes to the data and reflect stable patterns. Reclustering on the resampling subset was used for this purpose. Comparison of partitions between runs were performed using the adjusted rank index and adjusted mutual information metric. Both metrics measure cluster consistency across different partitions, and higher values during testing confirms the stability of identified structure. And the previous described pipeline in this slide you can see schematically. In addition to the main steps, the diagram includes two extra steps. And first relates to identifying the most informative features for each cluster, and second involves comparing the distribution of these features values between the identified clusters. Next, the results of the pipeline work will be represented using MRI subset. As an example, this example not included in the printed version of the work due to volume limitation. So we will take the opportunity to use it now. And the slide shows two types of projection. On the left, the results of reapplying UMAP after sequential dimensionality reduction. On the right, a direct projection into three-dimensional space from the original feature space. And each algorithm is represented by one of the four projections. Despite differences in method, all identify a stable cluster predominantly consisting of Alzheimer's disease patients. In the images, there are red clusters, and on the left pairs of graphs is green clusters on the right image. This in turn indicates the presence of stable structure in the data associated with this pathology. This slide shows summary tables, and each contains two types of information. The distribution of diagnosis groups within each cluster and the distribution of diagnosis group across clusters. The clustering result obtained by different algorithms are very similar and confirm our stability of the identified structure. And these tables allow for assessment of how well each method separates patient groups. They objectively evaluate clustering quality, internal metrics, as well as ARI and AMI consistency metrics were used. In the upper table, these metrics indicate cluster stability, while the lower table, the consistency of partitions between different algorithms. And in this example, clusters obtained by using HDB scan and agglomerative clustering show particularly good agreement. This slide presents an example of comparing the most informative features based on the clustering results from HDB scan. The left graph shows the top of three features and most informative features based on the clustering results from HDB scan. Left graph shows the top of three features with the highest mutual information values for each cluster, and the right graph is a box plot that visually compares the distribution of these features value across clusters. And in conclusion, I would like to briefly summarize the main results. In our study, we implemented a formalized pipeline for analyzing higher dimensional medical data with pronounced imbalance between the number of observations and features. Particular attention was given to validating results using both internal metrics and procedure for assessing cluster stability and statistical significance. Our experiments revealed stable structure in the data. The obtained results demonstrate statistically significant difference between groups, which may indicate the presence of new patterns in the data and provide a solid foundation for further research into Alzheimer's disease biomarkers. Thank you for your attention.
Thank you, Nadezhda. Please, questions from the audience. I have a small question. So I know that this is not the first work in this area, and even by your group, it's not the first work. So I wonder, how could you compare the progress of your new results compared to the previous ones? I think last year you also had a talk about like some approaches to this problem of dementia, which is very important. So how would you compare the new results?
Of course, you're right that it's a very important investigation, but at the same time, it's a very difficult investigation. About progress, I can say that with work combine all our ideas that we find from another investigation, and I think it's a step forward, and we now understand how we can process this data, and now we understand that the medical researchers don't understand this data very accurately. It's a very interesting investigation, and I think we will go in this direct. Thank you.
So it seems you are close to the breakthrough with some great new conclusions.
Can you repeat it?
I mean, you are close to the breakthrough, which means like the new great result and some new insights on the problem of this brain.
Thank you. You're right. It's a new result.
Yes.
It's very interesting thing for us.
Thank you. Do we have more questions meanwhile? No questions from the audience, apparently. Thank you, Nadezhda. Thank you. Let's thank you again. And we are coming to the next talk by Gleb Slipenkov. Gleb, could you please share your screen?
Yes, of course.
You can. Yes, we can see you. Very nice.
Before I start, let's check the slides.
Yes, we can see your slides. Yes, very good.
In such a case, I think we may start. Hello, everyone. My name is Gleb Slipenkov. I am a postgraduate student of St. Petersburg State University. And today I'm going to present you my report on a blockchain-enabled message broker approach for secure cross-organizational secure data transfer systems. So let's start with mentioning the fact that cross-organizational secure data transfer is crucial for modern information societies in such fields as finances, government, and some industrial areas. And it's especially challenging to implement such systems if you have to rely on public networks due to well-known increased risks of data loss, data corruption, and some other security risks like unauthorized data access. And blockchain has the potential to enhance existing identity mechanisms because it has three main advantages. The first one is fault-tolerant by design, and its fault-tolerant capabilities is significantly better than those of non-blockchain solutions. Blockchain by design is capable to work in unreliable public networks, being separated into multiple clusters owned by completely different counterparties. And last but not least, it provides smart contracts for secure data transfer process customization, which allows you to build different scenarios for specific purposes. That's why the main goal of our research is a proposal of a new approach, which will use blockchain in order to enhance the existing SDT systems characteristics. This approach should be based on existing approaches, and we should combine the advantages of such approaches, which will be described on one of the following slides. And it should overcome the transfer data size and scalability limitations specific for existing approaches. And one more advantage is a convenient message broker-like architecture, which I will be described also on one of the following slides. Besides this main research objective, we have an additional one, and it is related to potential AI-driven improvements, mainly related to dynamic load balancing and anomaly detection subsystems for such a blockchain solution. Now let's discuss what approaches exist nowadays. And the first one is a blockchain as a data access interface approach. Its key feature is the storage of the data completely off-chain in some non-blockchain storage, like relational database, object storage, or something else. And this approach supposes that blockchain is utilized for managing the control to this data, metadata recording, and storage of the transaction history of all the modifications and requests to this data. It's quite widely used in such areas as healthcare and other big data sharing applications, for example, like oil and gas sector, research, and some general applications. Of course, this approach has some drawbacks, and the main one is a lack of notification mechanism. Hence, such a system could be used for data sharing, but it's not suitable for data transfer tasks directly. The next approach is a blockchain as a data transfer tool, and this approach proposes storage data both on-chain and off-chain. And here, blockchain fully orchestrates all the data transfer process. Such approach is also quite widely used, especially in Internet of Vehicles tasks. And also, I was able to find some research related to peer-to-peer file storage and sharing and data transfer between fork nodes. Due to this mixed data storage type, we have key drawbacks of such systems related to limited scalability, because the data storage on blockchain implies into its replication to all the nodes. So the more nodes, the bigger the overhead of the data transfer. It also implies into strict data size limitations. Before moving on, let's compare such approaches. And I need to clarify that the key difference is related to data storage scheme and data transfer methods. So the first approach supposes the data is stored off-chain and transferred using some traditional methods, while the second one proposes a mixed data storage scheme and some blockchain-based data transfer mechanisms, mainly smart contracts. Because of these differences, the first approach systems usually have higher scalability, lower complexity, and smaller off-chain footprint. And they are suited well for tasks where you need to control access to some large data sets. The second systems are better suited for small data sets transfer when you need to focus directly on the transfer task. The key conclusion we should make from this slide is that existing solutions have either strict limitations on data size and scalability, or do not provide notification mechanisms required for data transfer. Before we move on to our proposal, let's discuss what is a message broker-like architecture. It's an architecture with the following features. Blockchain acts as a data transfer tool. Data process is organized in the publish-subscribe way. So here is Here exists data producer and some data consumers. And the data flow itself is separated into some topics. Topic is a data flow unified by a list of consumers or some maybe theme. In fact, these features are similar to those of existing message brokers, popular message blockers like Apache Kafka and RabbitMQ. A typical theme of such solution is presented on the right side of the slide. And of course, blockchain is already used as a system with message broker-like architecture. For example, it was used as an alternative for RabbitMQ in OpenStack message queues. And here is an example of usage as of blockchain usage as a tool for blockchain interoperability when you need to move data from one blockchain to another. The key drawbacks of these solutions is the direct usage of blockchain ledger, which, as I mentioned before, drastically limits their scalability and data size, transferred data. Now let's move on to our proposal. In order to overcome the existing limitations, we propose the usage of the combination of existing approaches, mainly blockchain as a data access interface and blockchain as a message broker. So it will be the system in which data is stored off-chain, but the data flow between consumer and producer is organized in a message broker way. In order to implement such a system, we require the following components. The blockchain itself has a core system components responsible for all data flow orchestration, smart contracts, which will implement the secure data transfer process, and each counterparty, named organization here on the next slide, should have its own private storage, accessible only by this organization, and some special applications, connectors, which acts as a mediator between blockchain, data storage, and end-users of the system. The data sending process is organized in the following way. It could be separated into 3 stages. The first stage is data sending itself. On this stage, the sender should send the data to its organization connector, which stores the data in private organizational storage and stores the metadata on blockchain. And blockchain sends a notification to the receiver organization, mainly to its connector. At the second stage, the connector requests the data from blockchain. Blockchain should verify the permissions to the data, and if permissions are acquired, should request data from organization 1 connector and prepare it for sending, for example, by encrypting or signing this data. And after the data is prepared, it's sent back to organization 2 connector, which stores the data into its organization private storage. And here the last stage begins. The last stage is a notification sending stages. When the notifications are sent back to blockchain and recorded in blockchain ledger, and also sent back to sender and to receiver of the data. Now let's discuss some technical details for such a system implementation. And the main one, of course, is a selection of a blockchain for such a system implementation. And according to related works, the best choice is, of course, a blockchain, a private blockchain with some implementation of BFT algorithm. Unfortunately, if we will use the one-layer BFT blockchain, it has some known drawbacks related to performance and scalability. For example, if you are considering the BFT Smart consensus algorithm, it reaches its peak performance only on 7 nodes. So it's completely impossible to use it for large clusters. That's why we propose the usage of 2-layered blockchain scheme. The first layer is called a partition, and it consists of small PBFT clusters up to 7 nodes, and is responsible directly for data transfer processing. These small clusters are unified into larger 1 clusters, which utilize rough consensus algorithm, and which main purpose is system management and data replication task execution. So the data flow itself should be also separated in the topics and partitions, like it is performed in message brokers. Topic, again, I remind you that it's data stream unified by theme of consumers, and partition is a subdivision of topic. Such a separation provides the following benefits. Main one is the simplified horizontal scaling, because in order to scale your system, you just either need to add some new small PBFC cluster or increase the number of nodes of some of existing clusters. And it also improves the load balancing characteristics of the data flow. So what are key advantages of this proposed system? It provides a loose coupling between sender and receiver, because they are not interacting directly with each other, they interacting only with blockchain from both sides. It has enhanced fault tolerance and scalability characteristics compared to both non-blockchain and blockchain-based solutions. It has a convenient publish-subscribe interface, similar to one of method brokers, and it's highly customizable via smart contract usage. Now, let's mention some possible AI-driven enhancements for such a system. And the main one is an anomaly detection subsystem, which should be utilized for metadata tampering detection and unauthorized access detection using some deep learning techniques, and dynamic load balancing tasks performed by some reinforcement learning agent operating with node capacity, latency, and load history task data. These are one of the main directions for the future research. So now it's just a concept. I could not deepen in the details of this enhancement, unfortunately. So now, what are our future plans? Right now, we are finishing the functional prototype implementation, and our next stage will be the performance testing of it. And in case we are not satisfied with the performance testing results, we will perform some optimizations of consensus algorithm, maybe by selecting other blockchain implementation or selecting other, just change the consensus algorithm. And the main one research directions are related to, of course, AI-driven enhancement development. Now that's all. Thank you for your attention. I'm ready to answer your questions.
Thank you, Gleb. These questions from the audience. And I actually forgot to announce that we switched to the next workshop, because this is a workshop on blockchain technologies and applications. So where we have two papers, this is one of them. So questions from the audience? No questions? Okay, I have a small question to clarify, but I'm a co-author, but still I'm concerned about the scalability. And you said already that the PBFT that you considered will not be scalable enough, but this proposed scheme, on your opinion, yet analytical opinion, it should be scalable enough to support a lot of nodes and a lot of data running on the system, being stored in the system. What is your expectation? And do you expect that there can be some issues that will be fixed on the next iteration of the consensus algorithm, like you mentioned?
Thank you for your question. Let me think a bit.
Well, in general, so what kind of scalability issues you can expect in your proposed solution? I would rephrase it in a simple way.
The main trouble is related, of course, to load balancing between these clusters. Of course, it will be quite easy to make some small cluster fault if you will not balance the load correctly. For example, if too many messages will come to only one partition, and we should be especially careful with these points in order to separate the workload better. This main issue I think we'll have to face. And the next one maybe will be related to Raft consensus algorithm limitations, but it's a point of other research. So I'm not yet ready to make any assumptions on this direction. But the main one, yeah, it should be related to load balancing issues.
Okay, thank you. No more questions? Thank you again, Gleb.
Thank you.
Thank you. And we are switching to the next talk in this session, and the talk by Jasur Kiyamov and the co-authors. And I believe the Jasur will present by himself. Jasur, can you hear us?
Just a minute, can you hear me?
Yes, we can hear you. So please share your screen and start when you are ready to start.
Can you see me my presentation?
Yes, but maybe you can make it full screen or enlarge a little bit, because we see like almost 2 slides at the same time.
Okay.
Yeah, yeah, that is good. Yeah, thank you.
Okay. Good morning, Representative colleague. It's my pleasure is presentation related our joint research entire transaction focus in the essential task of the enough stability and security and distributed system, especially in the financial and blockchain sector. Today, organization is face contrast risks according with the unreal date, malicious attack on dictated market fluctuation. Even small instruction transaction forecast can be lead to substantial financial losses, fraud, or system instability. Therefore, there is a growing demand for intelligent data processing. Method can be only rather than intelligent and consistent, but also extend heightened pattern for occurrence future presentation. Our solution can be a synergy of two the technology. First technology is consensus algorithm P50 and Raft. P50 Raft with clean structure transaction date. First technologies will be use LSTM neural network, which enough analyzation time series and providing accurate transaction for us. In this slide, we see that brief expand to consensus algorithm and the heart of the approach. First of consensus is PBFT. In this consensus, we designed operation when one-third of the nodes behind malicious, enough the date consensus of the presentation attack of the firewall. Second stage of system consensus is Raft algorithm. In this Raft algorithm, optimizate for simplification and receiving in the less open environment, handle nodes failure without compromission that integrate common in the distribution that cloud service. By combination in this algorithm, we created found reliability cleaning and structured transaction that with ascension for the machine learning. In this slide, we will work in two system integrate and some transaction processing working workflow organizations as PBFT defense and installation validation. You can receive and clear submission transaction request, and PBFT validate the consensus authorization and process attack. Only the valid date processing to the next stage. In the next stage will be will be transaction for RF technology replication order was a valid transaction. Enough in that synchronization reduce randomizer. And next stage will be system with LSTM transaction for forecasting. In this stage in cleaning structure and time series that be fed into the LSTM neural network. The model analyzing history patterns and prediction future transaction. This multi-layer approach improving both the reliability forecast accuracy. Let's dive deep in step-by-step data processing. Step in first, collection as the transaction data and cleaning the using P50 raft element, duplicate inserting and anomalies. Next, normalizing that and enough consistent scalability, improve modeling conversion. Next, evolve creating time sequence transaction windows, providing context for the produce. In LSTM model, this training structure and time serial data. Next step, evolution model occurs using standard metrics and visualization result test modeling related transaction data. For the transaction forecast, we using deep learning archive and one short-term memory network. No ability handle complex text-portable dependencies. The architecture has been included an input layer which recently normalized time transaction date, two hidden LSTM layer with 102.8 and 64 neuron capability in the selection long-term dependency and filtering noise, a liner out processing precise transaction forecast. LSTM memory mechanism, model effect, capability pattern, even noise distribution environment. In this slide, you can see all consensus P50 raft and neural engine LSTM several signal advancing up to 50%, reducing in the prediction error compare grid resistant to noise anomalies and mechanism depth, stability and structure transaction following, application with critical areas such finance, blockchain, and cybersecurity. This integrated approach enables the development of the smart prediction systems for distributed environment. This slide, can you see a result? We conducted series of experiment to the evolution of the method. The key result are as following. Without P50 and raft, the root mean secures error. Research, you can see 0, 1, 100 point, 82 reflection hidden volunteer and poor data quality. After applying P50 and LF and raft pre-emission, RSEM dropping, can you see and 0.47 confirm improving data structure and modeling performance. Additionally, we observe noise important in reduction function, leading to the more stability within transaction prediction. Results from the two structures level can be seen. Network combined network protocol is fast transaction environment consensus. Can be see systems of data of the correct error improved data minimalizing look optimization and the research network traffic and access processing. First of all, the combining using P50 and raft providing storage protection and malicious attack. In this slide, we can see algorithm of performance, asymmetry of the accuracy, reliability network verification algorithm using accuracy neural network. This ensures analyzing comparable and actual overall performance. Evolution of the models detect and improve the network such cyber attack for the node failure. Analyzing modeling fast forecast system load on the historical data, enabling resource optimization and proactive system adaptive. In conclusion, I will say in research department that the combining algorithm PBFT and Raft consensus with LSTM neural network substantially and another data recently in distribution system significant improvement transaction forecast accuracy and increase resistance to the noise anomalies and malicious attack. This method is especially relevant for the blockchain platform, financial application, and distributed computing, where transaction accuracy are critical of the previous role on system instability. In future, integrate OSTEM the hybrid models such as transformer for cool future boost clouds and system station. Thank you for attention.
Thank you, Jasur.
Thank you.
Thank you. So, other questions from the audience, both online and offline? Yes, please. We have one question in the audience. Could you please come here, because I don't think microphone is good enough to hear you. And I see we have one question from the online audience. We will go to this later on. And come here.
Thank you for your good presentation. I have one question. Why did you choose Raft algorithm as a consensus algorithm in your field? Do you understand my question?
Thank you for your questions. I will be.
There is a lots of consensus algorithm, but you choose the Raft algorithm, right?
Yes.
Why did you choose that algorithm for your research?
In my research, I choose Raft is heavily nodes failure without comparison data integration. Is simply for less hospitable environment is Raft algorithm is a fault algorithms. As a virtualization system, can be used in second segment stage and layer by the using is and natural layer in nodes can be aggregate transaction and stage B analyzing with in next stage with LSTM neural network can be LSTM analyzing historical pattern and future transaction can structure time serials data fed into the neural network. Thank you.
Okay, thank you for answering. Thank you.
Thank you. And we have another question from Gleb. So Gleb, please.
Yeah, just thank you for your presentation. Could you please move back to slide number 4? It's slide number 5. Oh, yeah, okay. So I apologize if you have mentioned it, but I did not understand correctly. What do you mean by saying transaction forecasting? Does it mean that LSTM predicts if transaction will be rejected or applied before the consensus round, or it has some other meaning? Because I see that LSTM is on this diagram is after all the consensus rounds. So I do not understand its role in the system. Please clarify this point, please.
Thank you, Gleb. In this slide illustration of the after the end transaction, after the transaction P50 and graph can be analyzation and narrow LSTM model, narrow networks can be will be C and structure time series date, and the model in this model analyzation history partner and prediction future transaction, and will be show anomalies in this network. Is it and multi-layer approach is data derivatives can be helped further in this blockchain network for the using and transaction will be can be see anomalies or no. Thank you.
Okay, thank you for your question and for your answer, sorry.
Thank you. Do we have more questions? No. Jasur, thank you very much.
Thank you.
And with this, we conclude our section on blockchain and distributed ledgers, technologies and applications. Thank you everyone for participating, both offline and online audience. And see you next time. Bye-bye.